Hello, folks. This is Notes 13. We're going to work on some components of deductive reasoning. You might remember deductive reasoning from... Is my mic on? It's on, right? Yeah, okay. You might remember deductive reasoning way back when we talked about inductive versus deductive. It's reasoning logically, following the rules of logic from known facts to a valid conclusion. If you do it right, your conclusions will always be valid. Now, before we dig into this particular worksheet, which has two very specific small components, I want to go a little bit wider. If you're 16, then you're a teenager. Can we agree with that claim?
Yeah.
Okay. Dylan, you're 16, aren't you?
Yeah.
Okay. So if I say Dylan is 16, and I know this is the rule, can I make a valid conclusion? Yeah. If anyone who's 16 is a teenager, that's the rule, and Dylan, a specific case, is 16, we can then say, therefore, 3 little dots, Dylan is teenager. Agreed? Yep. Now, forget about this part for a second. This rule still exists. If you're 16, then you're a teenager. Ash, are you 16?
No.
But are you a teenager? Okay, so if I say Ash is a teenager, can you make a conclusion? We don't know if she's 16 or not, besides the fact that she just told us, because there are other teenagers that are involved. Could be 13, 14, 15, 17, 18, 19. So we cannot make a conclusion with that. I'm going to say that Layla is not 16. Can we make a conclusion about that?
That she's not, only she's not 16.
Right, which isn't another conclusion. That's just what we got. We can't make a conclusion about that because she could still be 15, so we can't say she's not a teenager. All right. This is going to surprise you, I know, but Mr. E is not a teenager. That's me. Can we make a conclusion based on that?
You're either younger than a teenager or older.
Okay. So relative to this rule, if you're 16, then you're a teenager. Mr. Erlin is not a teenager, therefore. Well, that's the definition of teenager, but based on this rule, I'm not 16. I can't be 16 because if I was 16, I would have been a teenager, and I'm not a teenager. Everyone agree with these 4 examples? So what we just said is that if I've got the original conditional, P implies Q, if 16, then teenager, that's true. In other words, Dylan's 16, he's a teenager. If I take the inverse of it, oops, not P implies not Q, Layla is not 16, we were unable to make a conclusion. This is not necessarily true. When we do the converse, we said Ash is a teenager, but we don't know how old she is. That's also unreliable. I can't make a conclusion based on that. But when we do the contrapositive, it's reliable. If Mr. Erlin's not a teenager, then he can't be 16. So overall, we see that our 4 really important structures of conditionals have this relationship: true, false, false, true. Remember when we did our work on traversability and turned that into inductive versus deductive reasoning? What pattern might you look for in here and say, maybe it's true? Someone come up with a pattern and tell me what goes on here. What do you see as a pattern?
Is T and F stand for something?
Mhm. T is true, F is false. Yes, Aaron.
Only a positive or a double negative is true.
Okay, in other words, the first one is always true, and the second one is always true, but the middle ones are always false? If we do it in this order?
If the first one is true, then the last one will be true, and the other two will be false.
Okay, you guys agree that this pattern says that? If the first one's true, then the last one will be true, and the middle ones will be false. I agree with this data, that's the pattern. Just as we did before, let me give you some new data. If 90 degrees, then right angle. True or false? True. Now let's do the next one, the inverse. If not 90 degrees, then not right angle.
True.
That's also true. Now let's do the converse. If it's a right angle, then it's 90 degrees. True as well. Last one, flip it and negate it. If not right angle, then not 90 degrees. If it's not a right angle, then it's not 90 degrees.
True.
Because if it had been a right angle, it would have been, or it would have been 90 degrees, it would have been a right angle. So how's our pattern holding up? Bad, but not totally bad, right? Some things are still holding up.
The true is still there.
The true is still holding up. The first part of Aaron's claim that if the original conditional is true, then the contrapositive is also true, holds up in both cases. Is there something else you notice?
They're all in the middle.
The middles are the same, right? These are both false. These are both true. With me on that? Now, that was inductive reasoning, looking at a pattern. We know that's not super reliable, but it's a good way to get started. We did Venn diagrams recently. And if I want to express if P, then Q, P is on the inner circle, and what goes out here? Q. Now, I'm going to test these things, each of them. P implies Q. If P is true, I want to see if Q is always true. If I'm in P, I'm inside here. For example, let's say that if you're in Mill Valley, then you're in Marin County, right? If you're 16, then you're a teenager. Teenager is a bigger category. There's other things that are not 16. Marin County is a bigger place. It has other places besides Middle Valley. But if I'm in P, can I reliably know that I'm inside of Q? Everyone agree? If you're in Mill Valley, you got to be in Marin. So this one is true every single time. Now let's look at the inverse. If you're not P, then we're not Q. This is what we're trying to prove is true. So where is not P? It's somewhere outside of P, agreed? So it could be here. Could it also be here? Those are both outside of P. And since there's two possible locations, do I know whether I'd be inside of Q or outside of Q? No. So this one is unknown. Okay, let's try the converse, where we switch them, Q to P. So now the Q is true, and I want to see if it's a P. Well, here's a place where the Q is true, but it's not P. Here's a place where the Q is true, and it is P. So is this statement reliable? Do I know where I'm going to end up, whether or not P is true? I don't. That's unknown. If I know that I'm in Q, I don't know whether I'm in Q and inside P, or whether I'm in Q but not inside P. It's unreliable. What's the last case? Not Q implies not P. So now I'm outside of Q. That's here. This is the only place to be outside of Q, isn't it? And if I'm outside of Q, is it confusing as to whether I'm inside P or outside of it? No, we know that we're outside of P. This is reliable. And is this not exactly the pattern we recognized? That these two will have the same truth value, and these two are unreliable. 5, I'm with you. 3, I'm sort of with you. I'm not sure where this is going and what we're going to get out of this. 1, just P, no Q. Okay, good. Hands down. I have a way of remembering this that I hope is going to help you more. What we're looking to get to is a point where you can make valid conclusions based on what you've got in front of you. Right now, you do that with context, right? If you get a 90%, then you get an A. And then if I tell you, you got a 90%, can you make a conclusion? Sure. If 90, you get an A. Therefore, if you get a 90, you're going to get an A. No problem. What if I tell you you didn't get an A? You didn't get 90, because if you had gotten 90, you would have gotten an A. What if I told you you did get an A? You guys are digging in your brains, trying to figure out the reasoning of this. What I intend to teach you is the formatting so you can apply this to any context, even one that's not as familiar as this one. This should be doable for you because you know this scenario. 91, 92, 93, 94, all those things are A's. But here's what I'm going to do as my example. P implies Q. I'm writing out the original pieces again: inverse, converse, contrapositive. Coming up on lunch pretty soon, and I'm just sitting here thinking about a burger. See my burger? Now, what is this? I know my art's not very good, but what is this? It's a bun. What's a bun made of? Bread. What's this down here? Bun. What's it made of? So in other words, if I know that this is bread, don't I know that this is going to be bread? Those are both going to be the same. The top and the bottom of your burger are going to have the same stuff. Now, I'm really hungry, so I'm going to have a double decker. But before we get there, given a choice, raise your hand if you would eat a burger, like ground beef. Okay? Many of us, hands down. Raise your hand if that just made you throw up a little bit in your mouth and you would much rather have like an Impossible Burger or a Beyond Burger. Go ahead. Okay? Hands down. What if you're a classic? You like the Garden Burger? Raise your hand. No? Okay. What if you prefer like a grilled chicken patty? Raise your hand if that sounds better as a burger. Hands down. What about a turkey burger? Wow, interesting class. What about a grilled portobello mushroom sauteed in balsamic vinegar? What about a slab of salmon? Nice fillet of salmon? No hands? What about a deep fried slab of fish? Nice piece of cod, like fish and chips on there, right? Okay, so here's the thing though. Everybody's got a different thing that they would want as these burgers. Some are going to be beef, some are going to be turkey, some are going to be Impossible, some are going to be garden. But do you agree that nobody's going to have like a garden burger on the top and a slab of beef on the second patty? It just sounds weird. So whatever these two are, they're going to be the same. If this one's true, so is this one. If this one's false, so is this one. We're going to use this analogy to make decisions about things, claims. So now, let's take a look at our packet for a minute. This packet uses traditional geometry knowledge that makes laws, rules that are really not that startling. But because they're not that surprising, they don't necessarily make it easy for you to see when you need to use them. So the law of detachment simply says, if I've got a rule, P implies Q, and I know that P is true, I can then say, therefore, Q is true. Question? Like if the law says if I'm driving in a school zone, then I must adhere to 25-mile-an-hour limit. After school today, I'm going to be driving in a school zone. Therefore, I must drive that 25-mile-an-hour limit. First problem. If Mark saves $30, then he can buy a new video game. Oh, look at that. Mark saves $30. What can we conclude? He can buy a new video game. Take a look at number 3. If you're 18 years old, then you can register to vote. Olivia's not 18. She can't vote. Go back to our burger. If 18, that's our P, then you can vote. That's our Q. Olivia is not 18. What are we starting with then? If P is you are 18 and Olivia is not 18, what is Olivia? Not P. Don't get into the voting yet. Can we agree that she is not 18? Now let's go back to our burger. Which of our burger begins with not P? The inverse. Is that good, reliable bun where when you look at the top, you know what the bottom is? Or is that mystery meat? I don't know what it is. It's going to be the same as this one, but I don't know what you put in your burger. So this one is question mark. We don't know what that is. So I'm going to say no conclusion. Olivia's not 18. That doesn't mean that she's not 20 and could be fine to vote. All right, this one makes me laugh. If you plan to attend prom, then you must purchase a ticket. What's our P? You plan to attend prom. What's our Q? You purchase a ticket. In this case, Sarah purchases a prom ticket. So we're starting off with a new fact. Is that P, Q, not P, not Q? You purchase a ticket is Q. Sarah purchases a ticket. So we're starting off with Q and we're trying to decide, does that let me make a conclusion? Can I go from there to some conclusion? Let's see. Look at your hamburger. Which one starts with Q? Mystery meat, right? This is not reliable bun. This is mystery meat. Since it's mystery meat, I cannot make any conclusion. Now, in your mind, are you saying that's ridiculous? If somebody purchased a prom ticket, of course they would plan to attend prom. Why would you buy a ticket if you're not going to prom?
Something happened.
Could be, but with this data, I want you to pay attention only to the structure, not to your reasoning. Go to page 2. The second law is the law of syllogism. This is really better phrased as a logic chain. And it says, if P, then Q. And if Q, then R. That means together these things. Like, let's say this. If you got a 90% on your test, then your parents will be happy. If your parents are happy, then you get to go out for the weekend. Overall, that means if you got a 90% in your test, then you get to go out for the weekend. Is that the only way you're going out for the weekend? No. Maybe your parents like, oh, you're tired. You can go out. I don't know why they'd say that. This is called a logic chain. If P then Q and Q then R, then together it's like P then R. Let's say I get on a bus in Mill Valley and I take it to San Rafael. Then I get on the bus in San Rafael and I take it to Novato. I really got on in Mill Valley and got off in Novato. That's really what happened overall. So a law of syllogism is when you can draw a conclusion from two conditional statements in which the conclusion of the first, my Q, is the same as the what of the second. Nope. The conclusion of my first is the same as the hypothesis of the second. So if it's Saturday, then Jake has a baseball tournament. If Jake has a baseball tournament, then he will need to pack his lunch. Is my conclusion of the first the same as my hypothesis of the second? Yes. Then I get to do the rest of these as my conditional. If Saturday, then needs a lunch. Try number 7, please yourselves. Go. Sure. Can someone volunteer what you got for number 7? Is this a case for a law of syllogism? Yes? Hudson, what'd you get?
I said if number is divisible by 12, then number is divisible by 3.
Good. If divisible by 12, then divisible by 3. Because those parts match. What about number 9? If it's sunny this weekend, then you'll go boating. If it's sunny this weekend, then you'll wear shorts. Sam?
If it is sunny this weekend, then you'll wear shorts.
But isn't that the second one? Does this one have the conclusion of the first one matching the hypothesis of the second one? It does not. So this one, we can't say a conclusion, no valid conclusion. It doesn't apply to the law of syllogism. Please flip the page one more time. This is now just practicing. And again, they're only giving you these 2 scenarios. I'm letting you use the whole hamburger thing. If I drive over the speed limit, then I will get a ticket. What's my P? Yep. What's my Q? Okay. So this is the rule. And now I'm given what? P, Q, not P, not Q. It's P, right? And what I'm asking is, can I make a conclusion?
No.
Well, it depends. What structure is this? When I start with P and I look at my hamburger, which one is it? It's the bun. Is that reliable bun or mystery meat? Therefore, I can make a conclusion. I know that Q is going to be true. That's my conclusion. I got a ticket. Answer is yes, this is valid. And doesn't this look just like the law of detachment? P implies Q and P. P implies Q and P. So here we'd say law of detachment. Okay, if Amanda goes to the restaurant, then she'll order a hamburger. If she orders a hamburger, then she'll get fries. If Amanda goes to the restaurant, then she'll get fries. What do you notice here? Good. Order a hamburger is both the conclusion of the first and the hypothesis of the second. These are then the hypothesis and conclusion overall. This is a logic chain. Sorry? Of syllogism. Okay, what about number 3? Read it for a second, please. What do you think about 3? Invalid. Good. Because it's neither the law of detachment, where we're given a second fact, not another rule, nor is it a law of syllogism, where the end of this one is the beginning of the next one. So it's neither. So you write invalid. Okay, please finish up this packet as your homework number 13, submitted in Canvas when you're done. Feel free to ask me questions as you need them.